Okay, welcome back as we continue on with the next part of this finish off for our intro to derivatives. So this is again is the stuff that we need to take into Maths 1, so we just need to be prepared to be patient. This one here is a bit of pre-work, and that square there implies that we've got an overall bracket, which we usually use as a square one, but it doesn't matter, it could be a big round one. And so we've got 12x squared plus 1, and it's all squared. So when we do our substitution, this is the issue here. Everything inside the outside bracket. Okay, so the temptation is to just do the inside bracket. It won't work. So we've got to let. Now I'm going to change it from u to m. Let m equal the ln of 12x squared. It's everything. So you've got to put the whole thing in to make that work. Okay, we can come back over and rewrite that as m squared. Okay, so the next thing we want to do then is recognize that if we're going to differentiate the ln, we have to do another one. So we're going to let n equal 12x squared plus 1, and that allows us to run back over here and write m in terms of ln. Okay, ln. So now we've got three equations from which we can build a chain. So we're going through three chains: dy dm, dm, dn. You must learn to do this. I'm sorry. You must come to terms with this. Okay, this kind of three-chain thing will definitely be one of your first assessments that you get, because they want to know that you can cope with it. Okay, so once we've got all of that, we'll be able to go and see clearly that y dash will be dy dx. We're still going to have dy dx. We're just going to go through all of the chains. Okay, all of the chains go. And so I'll leave that for you to enunciate. We'll just get on and do it. So let's do the calculus. There's a little bit of setup, a little bit of awareness, a little bit of complexity. Now we can go ahead and we can do the setup, okay, which we've done. Now we can do the calculus. How long will that take? The dy dm of m squared is 2m, 4 seconds. The dy dm, the m dn, because m is ln of n, dm dn is 1 over n. That was 3 seconds. N dx, n of x, is going to be 2 times 12, which is 24. x2 take away 1 is 1. I'm not going to write the little 1 there, and the constant has no gradient. So then we put them all together. 2m times 1 over n times 24x. Now we can go about thinking putting the m's and the n's back in. So 24 times 2 is 48. And I'll bring that x over. M is the ln of n. So we've got to put 12x squared plus 1 back in there. So that does that term. And then finally we're 1 over n. So it's 1 over 12x squared. So we can put that across here like this. 12x squared plus 1. Now, that is the horsepower that is needed to be brought by you to Math 1. Okay? That is the horsepower that is needed to be brought to Math 1 by you. Okay? So there it is. That's our y dash. Okay? Very straightforward one. If you're familiar with the chain rule now, you're getting used to it. Very, very straightforward. Okay. Try and be consistent in the use of your pronumerals. If you pull a pronumeral out from somewhere else, it might not help. All right, so the next one we want to consider is log of a quotient. And sometimes it's a lot easier to deal with the quotients by bringing them out. Okay, so we can do a bit of pre-work here. We could do a u substitution, And we could do a quotient rule on the U substitution. But why do it that way? We can do a bit of pre-work. We can do the log of the numerator, subtract the log, that's log law, of the denominator. So then all we have to do is consider doing each of these terms individually. So we're finding the dash of that, the part, and the dash of that, the part. Now this is where I think it helps to have expressions, because what we're saying is let's ddx this. ddx log x minus 5. Okay, no problem. What we need to do is recognise that this is a chain rule, so we're going to let u of equal x minus 5. So du dx is going to be equal to 1. That seems trivial. Over here, we can't have ddx for our chain, so we're going to have ddu, the log of u. And what does that equal? The ddu. I mean, these are logs. When we see this, we're saying log base 10. Okay. All right. So what we'll get is 1 over u, and then we put this chain together with this chain. Okay, so it's 1 times 1 over u, and u itself was x minus 5. Okay, x minus 5, but we've forgotten something. What have we forgotten? We've forgotten to put in anything, I'm not sure. ddx of log x minus 5 is 1 over x5. So this is where I love playing a little bit. So to help you along, I'm going to do the wolfman. That's the one I want. That one twice, please. And it just does it to me. And we go to this one. Make a double window. That'll be fine. And we'll have differentiate. We'll just do the part. Differentiate y equals the log. Log, and we'll just do that base 10 of x minus 5. Okay, and over here we can do it this way as an expression. ddx log base 10 of x minus 5. Okay, x minus 5. So there we get the same thing, x minus 5 log 10. Okay, so you can go through and check it that way, which is a good thing to do. So when we were doing our log base 10, what we needed to do was go back up. Where did you come from? What we needed to do was go back up and check our table, our definition. Okay, check our definition. So log base 10, look at this. It's 1 over x with the ln of a. So this is this change of base formula. So even with a 10, we needed to put the ln of a. So the ln of 10. Okay, so we're going to put the ln of 10 in next to it on the denominator. So the ln of 10, that was the bit that went underneath. The log base 10 and the ln of 10, we're going to put that in there, all under the base. So we'll expand this one out a bit further, so we can let m equal 2 minus 7x. So dm dx is equal, and this one here gets written as minus, we're going to ddx minus log base 10 of m. So there's our log base 10 of m. And that is going to be equal to our table. So we're going to have minus 1 over m log base 10. Okay, so here this one is just going to be minus 7. So we put them together. Now that's an interesting chain, isn't it? Because that minus came about from being in the logarithmic sum. So we're going to end up with a plus. So when we d dx minus log 2 minus 7x, we end up with plus 7 over 2 minus 7x log 10. I've got to warn you, that's quite a hard one. But now both of these can be put together as your chains. Okay, so y dash will become 1 over x minus 5 ln 10 plus 7 over 2 minus 7x ln 10. Okay, so just that little recognition that this is not your straight out ln, it's only e that has the one that doesn't have that extra bit in it. Okay, so if we're doing base 10s or base or anything else other than e, then we have to include the ln e. Base e will cancel itself out if we do that. Alright, so very, very tricky, isn't it, sometimes? So we've got a thing here where we're looking at u and v, so it's a differential of a quotient. So we're going to have, this time like this, v squared. So u is equal to 5x, 5 to the power x. So u to the power 5 to the x. We just did an example of that one. Right, so we can go through and recognise that u dash is going to be equal itself, but it's times the ln of 5. Okay, that was the rule that we picked up. Okay, so they're a little bit trickier. Okay, and for v, it's log base 5, so v dash is going to be equal to dv dx, okay, where v is equal to the log base 5 of everything in here. So I'm just writing it out so that we can do it properly. So we can let m equal x squared plus 9. So the m, the x will be part of the chain to get this v dash. We can rewrite v in terms of log base 5 m. So dv dm. Now in the same way that we just applied the rule to u and u dash and the one up here, okay, log base 5, what we're going to do is we're going to get m. Okay, so log base 5 is 1 over m, which we expect for ln, but we have to remind ourselves to multiply it by log base 5. This one here is just your normal 2x. The constant's gone. So we're going to put those two together as a chain. So the 2x will sit on top. So v dash becomes 2x over m, which was x squared plus 9, multiplied by, on the denominator, the ln of 5. Okay, so now we've got all 4 pieces of information. 1, 2, 3, 4. We can now put them all together. So u dash is 5x ln of 5. I don't want you to think this is necessarily what Maths 1 is all about, because I don't feel that it is representative of everything that's in Maths 1. But certainly it's a skill we're being asked to use. So in that sense, we can't really challenge it. Okay, would this be taken out for university education? I'm not sure that that's a wise thing to do. Not overemphasising it, but there's a lot of things that we wouldn't take out that you're not going to overemphasise. There's a little bank. I wonder if your journal's discriminating that. Is your foundation journal discriminating things that he emphasises and things that aren't? Things that are included in the course that aren't overemphasised. Okay? So what are those things? Very interesting. All right, so that's our minus sign now. B dash was this whole thing. Limit 5. And U was the original 5 to the power x. So I can just put that next to it. Surely I can just put that next to it. Okay, then this has a denominator for both terms. And the denominator was log base 5 x squared plus 9. So a bit of, I don't know what you'd call it. FM Olympiad. Does that put enough distance between us and Math 1? A bit of FM Olympiad. Why not? That's a bit of fun, isn't it? All right. So let's do these last couple. Yeah, this is definitely not FM Olympiad. This is definitely M1. Here we come, baby. Okay. So in this case here, we're looking to understand that we're going to use the chain rule. And so we're going to have to rewrite things in terms of these new variables. The calculus then is set up using Leibniz notation. And what we end up with there is e to the u, 2 seconds, brilliant, 5. And so y dash becomes the chain, dy, du, dx. You'll thank me later when you get problems involving these. 5 e to the u, and u itself was 5x. So putting in the chains is a good idea at this stage of your careers. Okay, so this is e to the 7x to the power 5, all raised to the power of a half. So this is going to be 3 chains. X is being to the power 5 times 7, then it's being e, then it's being square rooted. So we've got a little bit of work to do to get that out. Okay, so we're going to let, remember what I said to you, everything in the middle, e to the 7x, 5. Okay, very important you do everything. This can be rewritten now as m, rewritten now as m to the half. Okay, this one here, if we're going to differentiate it, really? 7x5? No. Chain rule, n is equal to 7x5. So that means m can be rewritten in terms of n. Now we're ready to do our Leibniz. Our chain rule, dy, dm, dm, dn, dn, dx. There we go. We get from dy to dx through m and m. 2-step chain rule. We can now do the calculus. So it's a half m, half minus 1 is minus a half. Okay, so it's 1 over 2 the square root of m. And I'll come back to that in a second. dm, dn. Oh, love that one. 7 5s are 35. And 5 minus 1 is 4. 35x4. So finally we put all the chains together for a y dash. And I'll just put this as 1 over 2 the root of m, which was e the n, 7x5. So that's just that term. That's just that chain. So that chain is going to chain together with that chain, and it's going to chain together with that chain. And all 3 of them will form the answer. So e to the n is 35x4 sitting on the numerator. E to the n, which itself was 7x5, just substituting them back in. And then down the bottom here we had 2 root e to the 7x5. I know it's a lot, but this is what you must do for Maths 1. Okay, you must have this for your Maths 1. Okay, e to the root of x, pre-work. Okay, a bit of pre-work before we get to doing any kind of gymnastics. E to the x to the power of a half. Okay, so nothing we can do about it. Let m equal x to the half. So we can rewrite y in terms of m. E to the m could have used u. So dy dm gets us to dm dx. Dy dx is there. So there it is, dy dx. Okay. So e to the m, what's the calculus, please? Dun, 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 dun. Easy peasy. M equals x to the half. What's the calculus, please? Dun, dun, dun. Half minus 1 is minus a half. And so we get that same thing again, 2 root x. So these two together chain to form y dash. Which is dy dx using our chain rule, which is e to the m, which is square root of x divided by 2 root of x. Okay, so we can do that. All right, how are we going? So I'll come back and do another video because it's about that time. So I'll just pause there. Be back soon.